Hello again. This is another video showing the build process of making a DeltaWing type car that you see here for rFactor, and how I use my tools and spreadsheets and everything. And let's see where we are at. The last time we did the engine, so it has all the performance specifications based on the little bit of provided data. And before that we did the general shape and dimensions and collision points and inertias and all that sort of stuff. Next in line are the gears and the diff clutch brakes tab, which speak for themselves basically. This will be a fairly short one because these are relatively straightforward, and secretly I've already kind of done them. So the specs say that there are 5 gears, which is set here, and I'm going to allow gearing and final drive changes. Not quite sure what is done on the real car. It's semi-automatic. I think it even has automatic upshift, but for now semi-automatic is fine. I have a slight upshift delay, no clutch on upshift. It lifts the throttle on the upshift. It has a slight downshift delay, so it has time to blip, and it does use the clutch on the downshift, which I'm not sure of, but that's how I'm going to set it up first anyway. And it blips the throttle on the downshift. The shift RPM is just a little bit above the peak power RPM, which seems to make sense. And then we've got a whole bunch of gears here, ratios, and final drive ratios, and bevel ratios. And here I can set the default ones, so I can change the look and feel of this gearbox. I can change the final drive, that's the shortest one, and you'll see the speeds change less than 300, and then we install the tallest one, and we hit nearly 350. This doesn't realize that the car may not have enough power or too much drag to hit those speeds, but it's just a theoretical trace. The default ratios may be adjusted when I go driving and it doesn't match the tracks very well, but it's a reasonable starting point. And to show you what it happens if I install gear 1, then it's 1235 first gear, so we change the speed we do in first gear, and the default was 10, and index 10 is this gear. So it's just a way to specify the default gears, and these final drives are probably physically not possible, but they're a nice way of getting a subtle change in top speed. Just shift the entire curve left and right, like that. Alright, fairly easy. And then the other thing is that the torque it can transmit while shifting is a bit more than the engine torque, which is usually doesn't occur, but yes. Diff clutch brakes, that's the next one. The clutch has a certain torque capacity, which is now more than the engine maximum torque, 1.6 times. Slight inertia, a bit of friction, that's fine. Differential will be quite important because this is a strange car, and I feel that on any car the differential does quite a bit, but on this car, as we don't have any front roll stiffness, so well, it's getting a bit complicated already, but this is probably a very important way to tune the general oversteer and understeer on and off power, because we have no real adjustable front suspension for that, and this sort of acts like another way to adjust the yaw moments. But it's a thing we'll have to decide on the track. So now I have it set at slight preload, 50 Newton meters, adjustable between 0 and 250. I'm not using the viscous differential, which may be a bad idea, but perhaps it'll turn out to be a nice thing for this car, but I don't know what differential it has, probably not a viscous. And then there is power and coast lock, all adjustable, and we have to just find out what is a nice value. We'll get to that in a much later stage. Brakes, we can make them temperature sensitive and heat up a certain amount. I won't do that at first, I just want to have consistent braking and then add those in later. There's a maximum torque value, and now how do you decide how strong do the brakes have to be for this car to have a certain g-force? Well, it's simplified here, but it does help a lot. It predicts g-force that I'll pull. So here are the parameters. The minimum strength I can have the brakes in the car setup is 60%. Naturally it's adjustable to 100%. And the default setting is 80%. If I make it 90%, you'll see that the G-force prediction goes up. So with the default setting and the front bias of 40%, which is in the data, there's more braking done on the rear tires than on the front tires. Then now it predicts 3.4 G purely by the brakes, and there'll be a bit more because the aero drag will cause some G-force as well. Is this correct? I think this is more than powerful enough, because at 100% strength the brakes alone can do over 4G, and I don't really know, but I think the entire car with aero drag is unlikely to hit this number, or this should be more than enough for the first tests. Some things I've done here is that rFactor has heating and cooling, which I haven't set any penalty for hot or cold brakes, so they don't really matter. But it's another one of those random numbers that you cannot understand. But when you figure out how it works, you can sort of add a number here. That's the heating in how many degrees per second of heat at a velocity, a rotational velocity of 100 radians per second, which is roughly 115 kilometers an hour. So this makes assumptions, but at least it changes the heating in a logical way. And if you have a heavier car and then the brake torque is a lot higher, it would heat up a lot more if you use the same heating value. But this looks at those things, looks at the torque of the brakes and says, alright, I have to reduce the heating value because you want 105 degrees per second temperature rise at this speed, and the more powerful your brakes, the hotter the brakes would get, but the math behind this adjusts that. So that's quite neat. Did that make sense? I think it didn't. So this time we did the gears and the differential, clutch and brakes, and next time it's time for the tires, which is the really interesting stuff. So tune in next time, and bye bye for now.